Hello, this video is about how to calculate for density and molar mass of a gas. So I'm going to do a problem first on density, then a molar mass, and then a trickier kind of molar mass problem. Okay, so let's start with density first. Here's my problem. What is the density in grams per liter of a carbon tetrachloride vapor at 714 torr and 125 degrees Celsius? Okay, here's my basic problem. When I first look at this problem here, I notice that I'm trying to solve this density, and I don't have any like P1s and V1s and P2s and V2s, so I only have like one condition. It hasn't changed conditions. So when I have only one condition, it hasn't gone from one spot to the next spot, I know I'm going to have to use pivnert in some way. Now if you go to your equation sheet for AP Chem, it really gives you density equals mass over volume, you can see here right in the middle. But to me, it doesn't really apply gas laws. So it's kind of helpful, but it's kind of not. Hopefully density is kind of in your head already. So that's really all you're given. You've got your gas constants over here, which are really important. 8.314. I know it has funny units right here, but we're going to use it in those units eventually. But these units, this gas law here is in kPa for pressure. This gas law is in atmospheres, you can see, and this gas law is in torrs. Okay, so let's move ourselves to this problem. Okay, so I want to solve a density. If you don't really know where to go, you want to take what you want to solve and do its equation. Well, density equals mass over volume. And then see what you can find from there. I do know I have carbon tetrachloride, so I can find its molar mass, which is kind of helpful. But I really don't know the mass or the volume. So I'm going to go to pivnert over here, and I'm going to rearrange the equation a little bit. Because I'm going to find how I can get density, or mass on the top and volume on the bottom. So if I take the equation, and if I kind of take P equals, I'll put volume on the other side, equals nRT over V. And now I'm going to take RT and put those on the other side. That's also equal to P over RT is equal to N over V. Now N over V is a lot closer to density. I've got V in the bottom, which is good, and my N is moles. And I know that if I have moles, I can always go into grams. So this is kind of the place I want to be right now. I'm going to solve for, in the end, N over V equals P over RT. This is what I'm going to solve for next. My pressure gives me 714 torr, divided by my R times my T. My T is 125 plus 273. I've always got to get into Kelvin. If you go to your equation sheet here, it does give me the R constant in my torr, so 62.36. Ooh, 62.36. So I can take my numbers and push them in my calculator. I'm going to first take my 125 and add to it 273. I get 398. And the reason I take a second to do that is because I want to see my sig figs. According to the additive rules, this is infinite sig figs. This has 3, but they both have the ones place. And the adding rule looks at the ones place. So my sig figs here is 398 because they both go to the ones place. So I've got 3 sig figs there, I've got 4 sig figs here, or actually infinite, because that's the R constant, and 3 sig figs on the top, so I really want 3 sig figs in my answer, which is 3 sig figs for AP Chem is like 95% of the time, easily. 0.0288. Now that's in units of, here I've got N over V, that's in units of moles per liter. That's really helpful, because what I'm trying to find actually is density, and density is equal to grams per liter. And I already have it as 0.0288 moles per liter. Well, really all I have to do here is convert my moles into grams. And I can do that with the periodic table. Carbon is a C, tetrachloride is a Cl4. So really I just have to find the molar mass of Cl4. That's a periodic table number. So if I take 1 carbon and 4 chlorines from the periodic table, I get 153.823 grams per mole. Periodic table number right there. So I can put that here. 1 mole is 153.823 grams. Punch those in my calculator. Now I still have my calculator that 0.0288 number. And I'm going to get 4.3, still on 3 sig figs, to 4.43 grams per liter. AP Chem says the proper way to do things is not to do sig figs until the very end. In other words, I keep the number in my calculator, all the sig figs that I possibly have, until the very end, and then I sig fig it at the end. Because really, if you sig fig here 0.0288 and have that in your calculator times that, you're getting a less precise of a number. So that's what the AP rule would be. Okay, so that's density. Now, You can go ahead and memorize this equation here. If we manipulate things around and have the big M represent our molar mass, this is the equation for density. You can simplify it to P times big M molar mass divided by R and T. But to me, that's another equation in my head that I can't afford. So the way I just solve the problem by thinking through it is the way I would go for it. But if you want to solve this problem using this memorized equation, that's all on you. We're going to hit up molar mass next. I want to show you once again how you can do it just using your brain. So you can see your second problem. Take a look at that. There we go. Calculate the molar mass of a gas at 2.5 grams occupies 0.875 liters at the left torr and 35 degrees Celsius. Okay, so here we go. Molar mass. Molar mass is equal to molar mass is equal to grams per mole. Oh, in units. So the units I want to find is grams on top and moles on the bottom. Well, they actually give me the gram spot already. That's pretty handy. 2.50 grams. Now really all I have to solve for is moles, and once I put that in this spot right here, I can solve for grams per mole, and my problem's done. So moles, I'm going to hit down here. How can I solve for moles? I see I have liters, I have pressure, and I have temperature. That screams pivot right there. PV equals nRT. And I am going to just solve for my moles here. So I'm going to put in my variables. I'm going to solve for N, R, and T. My pressure is 685 torr. My volume is 0.875. It's already in liters, so that's handy. I want to solve for N. My R factor, go back to your formula sheet, that's 62.36 because that'll be our torr value. And then times my temperature. It's 35 plus 273. So I always take a moment to do it in my calculator. That equals 308. Looking at sig figs, this is in the ones place. This has a ones place or infinite things, so this has to ones place. So this is 3 sig figs. 3 sig figs, infinite sig figs, 3, and 3. Once again, 3 is a popular number. If I put in my calculator says for n equals 0.03118. So sig figging that's 88. I could say it's 0.0312. I'm going to still keep this number in my calculator because that's my moles, and I'm going to stick it right into this spot right here. 0.031188. So now I just need to take 2.5 divided by that moles number, and I get a whopping 80.158, which I'm going to round to 80.2 for my 3 sig figs. And that's my answer. What's the molar mass? 80.2 grams per mole. Once again, there's an equation. You can manipulate things. Whoop. Go down. So if you take the equation and you want to move things around from the density equation, you can find that molar mass is relation to density. Or you can manipulate things in any way you want, really. But I think, once again, doing it this way is kind of the best way to go. So that's my suggestion to you. Now, number 3, I want you to take a moment first and think about number 3 before you come back to this video. It is a little intense. So take a moment and think about it. Hit pause. And then come back to me. I hope you hit pause. Okay. So you've already read the problem. You've already started thinking about it. You've already thought, how can I solve for it? If you already solved it all the way down to the very bottom, and you got 79.6 grams per mole, you got the right answer. But let's take a look at what the problem says. At first, when I read it, I'm like, oh my gosh, there's so many numbers. How can I make this sense? Here's how I would do it. I kind of draw a picture. Like, here's my flask. And they tell me that my flask, a large evacuated flask, has a mass of 134.567 grams. Okay. When the flask is filled with a gas, with an unknown molar mass, which is what I'm trying to solve here, it has a pressure of 735 torr, it has 31 degrees Celsius, and it has a mass of 137.456 grams. That's when the gas is filled in it. Okay, that's helpful. And the flask is evacuated again, emptied, and then filled with water. So if I fill it with water, then that's at 31 degrees Celsius. It has a mass of 1067.9 grams per mole. It also tells me the density at this point is 0.997 grams per milliliter. Okay, now that I have it all right there in that kind of picture, it's a lot easier for me to look for, and I know what numbers I need to find. So now I can actually go to solve the problem. I'm trying to assume it's an ideal gas, calculate the molar mass. So once again, I'm trying to find grams per mole. That's molar mass. Okay, so I really have 2 parts I got to solve for. I need a grams number, I haven't given that, and a moles number. Okay, once I find those, I'm golden. So let's start with my grams number first. I need the mass of my gas. Well, that's what I'm going to go over to my numbers here in the red, and I see the mass of the gas plus the flask is this. So if I take 137 minus the mass of the flask, which is right here, if I subtract those two numbers, I'll get the mass of just the gas. And I did that to get 2.889 grams. Okay. 2.889 grams. Right there, mass of the gas. Got that done. Now I've got to solve for the moles. Once again, in the mole spot, PivNerd is a great place to go, because you don't know what the actual substance is, so you can't convert to moles. So PivNerd is where I want to go. So my pressure, they give me the pressure of my gas, 735, times my volume, that's the volume of the flask. I don't really know the volume of the flask, but that's what this water is kind of all about. So, if I fill up the flask with water, I can find how much water is in there. And I have it by grams here. So I'm going to take this, I'm trying to find the volume, I'm going to take 1067.9, and then subtract from it the mass of just the flask. That'll get me the mass of the water, 134.567. If I do that, I get 933.333. Beautiful. Sig fig wise, they both have a point something, so I'd really have a point something here. So I'm thinking 4 sig figs in my head. Now I'm going to take that this is in our grams, and I need to find volume here, so I need to find it in liters. So I'm going to take my 933.333 grams and convert it from grams into milliliters using my density, because it tells me 0.997 grams is in 1 milliliter. And then I can go from milliliters, 1,000 milliliters in 1 liter, to find my actual volume. 4 sig figs in the end, just like I found right here. So I got 0.9361 liters. That's the number I'm going to put here, 0.9361. Equals N. I don't have that. Going on over to my pressure, or my gas loss constant. Here's my 62.36. 62.36. That's my torr value, and this is in torr. Times my temperature. This is all at 31 degrees, so add to 273. Do the math there. I get, oh, I didn't do it ahead of time. 301. 3 sig figs in that. I'm going to push buttons in my calculator at this point. I'm going to get a moles of 0.03629 moles. And that's the number that I'm going to put right here in my grams per mole spot. 0.03629. That's too many sig figs looking back at it. I should really have, this is 3 sig figs, this is 4, and this is 3. I should really have 3 sig figs. But I'm keeping all the numbers in my calculator. And I'm dividing the two. And I'll get a 79.6 grams per mole. 3 sig figs right there. And I got my answer. Alright, send any questions in the Google form. Good luck.